Okay, so this should be recording now, but today I'll talk about analyzing data sets in Jupyter, because you have the Olympics mini project coming up. So that'll be a lot of doing some data analysis and just learning how to use different things in Jupyter so you can make your tables and your plots and your scatter plots and histograms. So today I'll go over a PowerPoint, which will just be an overview of analyzing data sets in Jupyter. Then I'll do a demo on the Jupyter server. And then I'll give an overview of stage 1 of the Olympic mini project, just so people can have some clarity about the assignment if anyone has any questions. And then I'll give some time for Q&A at the end in case anyone has questions. So some key concepts we'll go over are reading and exploring data. So once you have a data set, the first thing that you want to do is you want to kind of look at your data so you know what you're dealing with. You're going to want to look at like the different columns, what data is stored in the columns, just so you know what you're dealing with so you can have a better idea of how you want to analyze your data. Then we'll talk about data cleaning. So sometimes your data might have some missing values. So I know you might have already encountered some not a number values. So the point of data cleaning is to kind of remove those values so you can continue to do your analysis. Because, for example, if you had a column with a not a number value, if you have a column with a not a number value and you wanted to take the average, you would get not a number for that average because you can't do the computation with that value there. Then we'll talk about parsing information. And what we mean by parsing is, let's say you have a data set where one of the columns is years, and you only want the data that's after a certain range because you want your data to be up to date. So then you would parse that data set so you only have your data from the year 2000 onward, or that's just an example. We'll talk about using .where and .group because those are two important methods that you should be pretty comfortable with for the Olympics mini project. And then we'll do a little bit of visualizing data using histograms, scatter plots, and line graphs. So for reading and exploring data, when you're first handling a data set, the first thing you should be doing is kind of exploring the data. So this would look like looking at the different columns, checking for inconsistencies such as not a number or missing input, or maybe the source you get your data set from doesn't have the data set organized very well. So you might have a column that's mixed up with integers and strings, and you'd have to get that settled out as well. So then you kind of want to have an understanding for the data type in each column so you know how you can do your analysis. Like maybe there's a string in one column, an integer, a list, and so on. So then you can start thinking about trends or information that you want to further explore. And then just remember, if you don't do this step of exploring the data, it's going to be difficult to analyze because then you're not going to understand what's in your data set. So for this example, I'm going to use a data set from Kaggle. Kaggle is a website that publicly provides thousands of data sets. And what I think is a really nice feature on Kaggle is that it has a usability score. So it tells you a good idea of if your data is messy or not, so you can use it for your projects or not. And then there's also forums on Kaggle, so you can get input from other people about maybe problems they encountered with the data set. So you have kind of a community where you can go and get some input on your questions or anything that you're worried about. So some data sets are pre-cleaned and others you will have to clean yourself, but on Kaggle, it will tell you if your data is clean or not. So if you just want to practice and you want to have a clean data set, you can actually see that on Kaggle that it is pre-cleaned. And Kaggle will provide information about which columns may have missing data, which I think is very important to know. And it can provide a summary of columns and their data types, which I'll go on the Kaggle website, so we can look at that in a little bit. So during this webinar, we're going to explore the data in the NASA exoplanets dataset. So as you can see here, it has a usability score of 10 right there, which is actually the highest usability score, which is part of the reason why I picked this data set. So this database contains information on all of the known exoplanets from NASA, and it gives us information such as the year that it was discovered, the mass of the planet, the distance from its host star, and it'll tell you in relation to what host star. So this is a screenshot from Kaggle. For every column in the data set, it gives us all of this information. So I'll show you in a little bit on the Kaggle website. So this column is called stellar magnitude, and then it gives us a little description of what's in the column. So it says it's the brightness of the planet, and the brighter the planet, the lower the number is assigned to the planet. So basically, the higher the number, that means the brighter the planet is. And then as you see on the left, it gives us a little histogram here. So we see that the minimum value is 0.87 and the maximum is 44.6. Which we can see 44.6 seems to be an outlier here from the histogram because the right half is missing. So that means that most of the data is concentrated towards the lower half. So we see that 97% of the data is valid, which is very high. And then only 3% of the data may have missing values. And then it actually gives us a bunch of information about the data. So it'll give us the mean, the standard deviation, the min, the max, and then different quartiles. So the 25th quartile, the 50th, which is the median, and the 75% quartile, which that's all very helpful information to have. So the first step you want to do is you're going to read in the CSV, which you've been doing a lot in your labs. So just as you do before, you will use table.readTable, and then the parameter that takes is the file name. So you'll have your file in the Jupyter server, and then you're going to you put that string in as a parameter of read table, and then we can see the table and kind of get an idea of what's in our data. So next, for example, I'm going to go over this in Jupyter after this presentation, but we're going to focus on the discovery year column. So the first thing you want to do is you want to extract the column as an array using .column, which is different than .select because .select will select a subset from the table, but using .column will give us an array, which is important because we want to do the operations on it. Then we're going to sort the data just to get a good idea of what the min and the max is. And we can compute what's called a 5-number summary, which is the min, max, median, mean, and standard deviation. And then NumPy has methods for all of these 5 numbers, so it's pretty easy for us to get a 5-number summary. And then we can also create a histogram to get a better idea of the distribution. So this is like creating everything that's on Kaggle that we can actually see on there. So the first thing we want to do is we want to extract the column as an array. We need the column as an array so we can compute all the values in the 5-number summary. And then we can print out these values to get a better idea of what values are in the column, or if there's something like we're trying to take an average and something's not working, then we can go through the values and see if there's not a number or something that may not be working. So here we have years set to the column discovery year. And then this is just a little loop that we can use to print out our years. So this is a for loop. So it's going to say for each value in our array of years, because remember using .column will give us an array. We're going to print out the year. And then obviously you're not going to keep all these print statements when you turn in your assignment, but this is just preliminary for you to get a good handle of what's in your data set. So next we can sort the data. So sorting a data can just give us a better idea of the range that the values span. And it can make it easier to find missing or not a number values because they'll usually be at the beginning or the end when you sort your data. So here when we print out our sorted array, we can actually see the min and the max. So then we know what range that our data spans. So this shows us that the first planets, the exoplanets were discovered in 1992. And then this data set is up to date, so it goes up to 2023. So we'll talk about the 5-number summary. NumPy has methods for each of these. So once we get our column, remember years is the array from the column that we got from the table. So we'll use our NumPy methods to get the min, max, median, mean, and standard deviation. So we just use the NumPy methods. Remember, it will take in the parameter of an array, and then it's going to return that value. So then we can have these print statements to print out all of our numbers, the min, max, median, mean, and standard deviation. So we see in this data set, it seems to be pretty balanced because the median is close to the mean. So the average is 2015 and the median, which is the 50% quartile, is 2016. So when we're exploring our data, we often don't just want to look at one column. So we can put the 5-number summary into a function. So given any table and column, we can easily compute these numbers. Because realistically, if you were looking at a big data set and you wanted to see these values for a lot of different columns, you're not going to want to type out np.min a million times. So by making this function, we can actually be able to do this for any column. And it's just important to note that because we're computing things like the min, the max, and the mean, the column must have an integer float data type. And you must pre-clean your data, because if there's a not a number value, you're going to get not a number for all of these values. So the way this function works is we give it the name of a table and the name of a column. And then we make an empty list, which we're going to store all our numbers in. And then we're going to get our array by doing table.column, and then the column that we put into the function. And then we're going to append to our list the min, max, median, mean, and standard deviation. And then the reason that we put it into a list is because we want to return all these variables at once. So by using this return statement, we return our list, which has our 5-number summary included in it. And then we can just print that out, and then we get all of our numbers at the bottom there. And as you can see, those are the same numbers from the previous slide, because this function is just doing the same thing that we did earlier. So another thing that is good when you're looking at your data is creating a histogram. So we can use np.histogram, and that takes the parameters a, which is an array, bins, which that's our number of equal with bins. So as you can see here, this one has 5 bins. There's actually not anything in the first bin, but we can count 1, 2, 3, 4 that have values in it. And then range is the number of values that the bins will cover. But this will default to from the minimum value to the maximum value, which is usually what we want, unless your data is really unbalanced. That's a situation where you wouldn't want to do min to max. So to plot the histogram, we can use the matplotlib function plot.hist. And then hist actually uses numpy to create our histogram. So it'll take in those parameters, and this will use matplotlib to show the visual histogram. And then if we wanted to add a title to this, we could say plot.title, which I think it's good to label your diagrams, just because in the Olympics mini project, you're going to have a lot of histograms. So when you're scrolling through, you're not going to get confused about what things mean. So if we wanted to plot a subset of the data, so let's say we only want to look at planets that are classified as gas giants, then we can use .where to get a subset of the table, and then we can use this data to make the histogram. So if in this example, we set gas giants equal to a subset of the table where the planet type is equal to the gas giant. So remember, .where will take in the parameters, a column name, and then whatever filter that we want to use. So this filter is that the planet type is equal to gas giant. So our second parameter is r.equal to gas giant. And then we can print out this table, and we can look and see that planet type is all equal to gas giant. And then it's important to note that before, this table had 5,000 some values in it. And now if we look at the bottom left, we can see that it only has 1620 in it now, because this is only a subset of the original table. So now if we want to plot a histogram for just the gas giants, we can make a new years column. I called this years GG to stand for gas giants. So we take the column using .column, and then we plot it the same way using plot.hist. And I use the same number of bins. And then we have our title, which is distribution of discovery years for gas giants. And then using plot.show will show our plot. So as you can see here, more gas giants were discovered in earlier years than in our previous histogram. So it's interesting to see how different subsets of the data can vastly change the distribution. Although this one didn't change that much, we can see some changes from the previous histogram, which I'll talk about more when I show the Jupyter demo. So if we want to group the data set, we can use .group. So let's say we want to find the top 5 years that have the most planets discovered. So the first thing we want to do is we want to group this by year. And what .group does is it'll keep the column that you give it to, and then it's going to create a count column that'll show us the number of entries per year. And then we can sort this, which will sort the table by the count column. So we have our highest frequency first, and then we can use .take, which will take in a range to get a subset of the top 5 years that will have the highest count. So here we group it by discovery years, and then it will keep the discovery year column. And for every entry, we're going to count how many times that year occurs. So it's going to shrink our table into 2 columns, discovery year and count. And count is just a frequency of how many times that year occurs in our data. So the next thing we do is we sort this, so we can see that now it's sorted in descending order, so the highest one is first. And then if we want to take just the top 5, we say .take, and then the parameter of this is a range. So we say np.arrange 0, 5. Because remember, we start indexing at 0, and then the second bound, the 5, that's non-inclusive. So it's really going from 0 to 4, because that would be 5 values, but it's non-inclusive, which is why we have to have 5. So that's saying it's going to stop at 5. So next, if we want to kind of group by multiple columns, so let's say if we wanted to get the top 5 years that Neptune-like planets were discovered during, we'll first use .where to filter the data, then we'll use .group to get the counts. So first, what we do here is we use .where to find where the planet type is Neptune-like, and then we use .group to group it by the discovery year, and then we use .sort to get it by the count. So remember, looking at our counts in our previous grouping, these are a lot lower because it's only a subset of the data, because first we filtered to only get the Neptune-like planets, and now we're getting the count of the years, but it's only the Neptune-like planets, not the full data set. So another thing you're going to have to do in your Olympics mini project is plot a time trend line. So if we want to plot the amount of planets discovered as a function of time, we can group by discovery year and then plot the discovery year versus the count. So as we can see here, the x-axis is time, because typically if you're plotting time, you're always going to want to have the x-axis be time. And then our y-axis is count. So this turns our count into a function of time. And we do this by first grouping by the discovery year, and then we plot x versus y, so discovery year and then versus count. So as we can see, we see a big spike here. So that shows that that year has the most planets discovered. And then we can also create a scatter plot. So scatter plots are typically used more for discrete data. And then we use .scatter, the parameters are x and y, to make a scatter plot. So if we want time on the x-axis and distance on the y-axis, every section of the data, so every point in the data, so let's say we have 1995, 0 in our data, then it's going to put a point down for each x, y in the data set. So here's my email if you have questions, and you can always check the Google Calendar for all the CA office hours. And then we can start with the Jupyter demo now. So first, I'll go to Kaggle. This is actually where I got the data set from. So as we see here, it has a download link where you can download the data set. So if you're following along with this, I can paste the link in the chat and you can go ahead and download it as well. Let me get the link here. Okay, so the link is in the chat now. And then what you would want to do is you would go here, click the download link, and then you can upload that to the Jupyter server, which I'll show you in a little bit. So Kaggle has a lot of resources on here. So we can see just an overview of the data set here. If we want to look, we can click here to see a summary of the columns. So this is saying that 7 columns have a decimal value, 5 columns have a string value, and 1 have an integer value. And then if we want to view things by column here, we can see all of our different columns. We can see which ones have missing values or maybe mismatched data. We can see the number of unique values. And then it gives us our 5-number summary. So like mean, standard deviation, min, max for all of these, which I think is a really nice resource, and especially because it has the histograms. And then you can move your mouse over these to see the actual count. So it'll show this for every column, and it gives a description of what's there as well. So if we go here, I'll make a new file. And to upload your data set, you'll just click this, and then you'll go to your downloads to click on it there. But I already have the data set in here, so that's why I don't need to upload it again. And then again, we can view this data set in Jupyter. So now we can start analyzing our data. So I'll go to the Olympics project first, and I'll take all of these imports from this template. So if you want to analyze data on your own and you can't remember what imports you would commonly use, you can just copy and paste these here. Because without importing these, you're not going to be able to use the NumPy functions or the matplotlib functions. So it's important to get our imports there, and of course the data science tables module as well. So the first thing that we want to do is we want to read in our data. So what I like to do is I like to set the file name as a string first into a variable like this. The file that we downloaded from Kaggle is called cleaned 5250 because that's how many values in the dataset are, and then .csv because it's a CSV file. And then I'm going to call the table NASA, and then we can read in the table as we've been doing. And then I'll say NASA so we can get a display of the table. So here's our table, and we can see all the different columns, and we can look at what values are kind of stored in the columns. But here I'll focus on the discovery year column like we did in the slides. So when we're exploring the discovery year column, first we need to extract the column as an array. So I'll say years equals NASA.column discovery year. And then remember, when you're saying .column, what's in this parameter has to exactly match what's on the table. So we can run this. Oops, I forgot to print it out. And then when we print out years, we'll get our array of years. So remember, like if I put a capital D in here, this is not going to work because it has to exactly match what's in the table. I know that's a common mistake that some people can have. So if we wanted to use a loop to print this out, we could say for year in years, then we're just going to print out the year. And I think this is helpful if some columns may have a not a number value. So we can scroll through here and find it. But obviously, before you're submitting your assignment, you'll want to take this out because this is just for your own exploration of the data. You're not going to want to turn this in and have us scroll forever when we're looking at your assignment. So we'll print that out. As you can see, that column was completely clean. There was no not a number value. So our years is ready to be analyzed. So if we want to find the minimum year, then we can just simply use np.min year. Because this will take in the parameter of the array that we just extracted from the table. If we want to find the max, we do the same thing. We say np.max of years. For median, it's np.median years. For mean, which is also the average, is np.mean years. And then our standard deviation is np.std years. And then we can print all of these out with print statements, or you can do it like this, or you can say print min year, just whichever you prefer there. So we can display all these to the screen, so we can see what numbers we're dealing with. And then our standard deviation. So if we run this, we get our numbers. So we see that the minimum is 1992, so that was the earliest year that the exoplanet was discovered, and 2023 is the latest. We know our median is 2016, which is the 50th percentile, and 2015.7 is our average, and our standard deviation is 4.3, which is relatively low for this data set. So let's say that you're going to want to get these 5 different values for multiple columns. That's a good example of when we would want to use a function. So to define a function, we'll call this the 5-number summary function. And then this will take in any table and any column, and it's going to give us these 5 values. So first we'll make our empty list of numbers, because that's what we're going to append our values to, so we can return them all at once. So we'll make our array, which will be the table dot column, and then the column name that we give it. So remember, in this function, this will take in any table and any column name. That's why I'm not using NASA or discovery year, because we want this function to work for anything. And then we're going to append to our list each value that we want to return. So we'll have our minimum, our maximum, our median, our mean, and our standard deviation. And then remember that dot append only takes 1 parameter, so that's why we have to type this out 5 different times. And then we can return our list, so we can use these numbers on any table and column. So for example, we could say print 5 num sum, because that's the function that we're going to use. And then the table we want to give to this is our NASA table. And the column we'll use, remember, columns are string values, and we want to use the discovery years. Oops, it's just called year. And then we can see that these values are exactly the same as these. The function just makes it easier, so we can apply this to any table or column. So we don't have to type that out every single time. So now let's say we're exploring the data and we want to make a histogram. So to do that, you could say plot.hist. We'll take our years array, because remember, histogram takes in the parameter of an array. And then we'll set our bins. So we want this histogram to have 5 bins. And then we'll give our histogram a title, just so that makes our code easier to look at. So we're telling whoever's looking at this exactly what's in the histogram. And we'll call it the distribution of discovery years. And then to view the histogram, we say plot.show. So when we run this, we'll get to see our histogram. So now we can see the distribution of discovery years. We see the most common bin is this bin here from 2010 to 2015 about. So let's say we want to make a histogram of just a subset of the data. So let's say here we want to look only where the planet type is equal to gas giant. So first we're going to have to get our subset of the table, and I'll store this in a table called gas giants. So we're taking the original table called NASA, and we're using .where to filter out the to get only the gas giants. So this will take the parameter of the column that we're looking at, so planet type. And then it's going to take the other parameter, the filter that we're giving it. So we want to look where this column is equal to the string gas giant. So we'll say r dot equal to, and then gas giant. So if we want to view our gas giants table, here you can see that this is a smaller subset of the data because this only has around 1,600 values, whereas this table has over 5,000 values. So now when we want to make our histogram, we can see how our distribution may differ given a smaller subset of the data. So we can say years gas giants equals gas giants dot column discovery year. Then we can plot a histogram given our years array. And we want to have 5 bins just like the other one. We'll give it a title. So this time we'll call it distribution of discovery years for gas giants. Because remember, we're only looking at the gas giants because we filtered out our table. And then we'll use plot.show to show our plot here. So when we run this, we can kind of see how this distribution may differ from the full data set. So as we see here, the gas giants has a bigger proportion discovered in the earlier years, rather than our full data set where more planets were discovered in the later years. Because this bin is barely visible here compared to the rest of the data, just because this has 3,000 values, where this has 500. It only goes up to 500, so we can actually see this column here. So this is important to think about, like in your Olympics project. You can think about how different subsets of the data may have a different distribution. So now let's say we want to get a count of how many planets were discovered in each year. We can use .group for that. So we'll say year groups equals NASA.group, and then we'll give it the parameter of the discovery year column. And then we can print this out. And we see that now our table only has 2 columns. So our new table called year groups has 1 column discovery year and another year, which is the count, which is how many times that year appears in our data set. So now we can sort this. So we'd say year groups dot equals year groups dot sort. And then we want to sort it by the count column because we want to see which years have the highest count. So we'll say count. And then the default is to sort this in ascending values, so the lower values are first. But we want to see which years have the most planets. So we need to change the parameter to say descending equals true. So our higher values will be visible. So when we run this, we see that now it's sorted by count. So we see that 2016 was when the most planets were discovered, according to this data set. So if we wanted to get the top 5, so our year groups top 5, we can use the .take. So we'll say .take, and then .take gives a range of values. So we use np.arrange to get our range, and we want the top 5. So we'll say from 0 to 5. And then when we print this out, we get only 5 values because we use .take, and we see 2016, 2014, 2021, 2022, and 2018 are the top 5 years. So the next thing that we want to do is, let's say we want to see the top 5 years, but only we're looking at the planets classified as Neptune-like. So we'll say nasa.where planet type are equal to Neptune-like. So remember, using .where will filter out, so we only get the Neptune-like planets. And then again, we want to group this. And then if you're more comfortable, you can split this up into different steps, or you can just keep appending your methods on. So we'll say .group discovery year. And then we're going to want to sort this again. So we'll say .sort descending. Oops, we want to sort this by count because remember dot group will make the count column. And then we'll say descending equals true. So now we can see we have our discovery year and our count. And these counts are a lot lower because we're only looking at the Neptune-like planets. So now another thing that you might want to do is you might want to make a plot of this. So we have our NASA table. This is the full data set again. So NASA.group by discovery year. And then we want to use dot plot. So this will make our time trend plot. So we want our x-axis to be time. And then our y-axis to be the count. So this is plotting our count as a function of time. Then when we run this, we get our plot. So we can see that the least amount of planets were discovered in 1995, and then there's a little bit of an upward trend, and then it spikes a little after 2015, and then we get a big downward trend. So this is just something that you'll want to think about when you're doing your Olympics mini project. So next we could talk about a scatter plot. So scatter plots are mostly used for discrete values. So if it's not a function, it's just a bunch of x and y values that we don't want to like connect like this plot. So let's say we want to do a scatter plot of discovery year versus distance. Then we can run this and we see all of our plots. And it's not connected like this other plot because this is a scatter plot. And we have our scatter plot of discovery year versus distance. So now we can go to the week 5 Olympics mini project. And these examples are very similar to stage 1. So we got our data set from Kaggle again. This is a Winter Olympics data set talking about different medals, sports, athletes. So let's talk a little bit about the questions and like what methods you want to use for these questions. So the earliest year for a Winter Olympics in the data set, the first thing you want to do is you want to filter out the not a number values. So you can use dot where to do this. You'd say are not equal to not a number. And then we can filter out the years. So the way that we would do that is very similar to this example. So we can get our years as a column from the array, just like this. And then we can use np.min to get our earliest year. If we wanted to examine the distribution, we can use our 5-number summary function to get the min, max, and average. And then plotting with the histogram is the same as this example. You could use plt.hist. So if we wanted to look at the age distribution of only gold medal winners, remember that we'll get the subset of the table first. We'll use dot where to get only the gold medal winners. And then you can look at the differences in these distributions with the full data set versus the subset of the data set. If we wanted to get the top 10 countries, the first thing that we want to do is we want to group this by country, and then we'll use dot take to get our top 10. For number 5, this is similar to number 4, but we'll need to group this by gold, silver, bronze, and total medals. So you'll have 4 different tables, and then you'll use dot take to get the top 10 for each of these tables. If we wanted to take the top 5 sports in terms of number of athletes, you'll first use dot where to filter out our number of athletes, and then we're going to group it to get our count, and then we can use dot take to get the top 5 again. And this is very similar for questions 7 and 8. And then for number 9, you can think about how medals are awarded to each participant on a team. So how does this change the results you have found above? So you'll see maybe that like team sports will have more medals because a medal is awarded to each participant on the team, versus solo sports may have less medals because it's only one person getting a medal there. So this is pretty much it for this presentation. So if anyone has any questions, you can feel free to unmute and ask or type in the chat. Yep, so if no one has any questions, I'll stop the recording and I'll upload this to Canvas for everyone to see if someone missed it and needs to see the recording.
Super. That was spectacular.